In this lecture, we would be discussing the econometric process and model building in detail. Let's review the 5 stages of the econometric process first. The first stage is data collection. The second stage is model formulation. Then there comes the stage where we do estimation. The fourth stage is evaluation of the model. And then the last stage where we do the policy analysis. Okay, let's discuss the first stage where we have to collect data, and while collecting data you should know the source of your data collection. There are 2 sources of data collection. The first one is the primary source and the second one is secondary source of data collection. Primary data refers to information that is collected first hand for a specific research purpose. Researchers directly go into the fields and they gather data through methods like questionnaires, surveys, observations, experiments, or interviews. On the other hand, secondary data refers to information that has already been collected by someone else for a different purpose. Researchers access and analyze existing secondary data to answer their research questions. Secondary data sources include official statistics, for example, data collected and published by government agencies, such as census data, labor statistics, economic indicators, and demographic information. While data can also be collected from different databases, online databases, repositories, archives containing a wealth of secondary data on various topics including economics, social sciences, and other fields. For example, the data collected from World Bank database or IMF is the type of secondary data. When collecting data for empirical analysis, several factors should be taken into consideration. The first factor is sample size. The sample size refers to the number of observations or individuals included in the data collection process. A larger sample size generally leads to more accurate and reliable results as it reduces the impact of random variation. For example, if you are collecting data on consumption and income of 100 households of your city, then the sample size here would be 100. Similarly, if you take the example of time series data, if you're collecting data on GDP of your country from the year 1990 to 2022, so the sample size in that case would be 33, because you are having data on 33 years. The second factor is representativeness. The sample should be representative of the larger population or phenomenon being studied. A representative sample accurately reflects the characteristics and diversity of the population, ensuring that the findings can be generalized. For example, if you are collecting data to study the consumption behavior of households in your city, and your sample includes households only from the high income or low income groups, then your sample doesn't represent the entire population of your city, which is essential for an accurate study. The third factor is potential biases. Bias refers to any systematic error in the data collection process that leads to inaccurate or skewed results. Researchers must be aware of potential biases, such as selection bias when the sample is not representative, or response bias when respondents provide inaccurate information. After collecting data, there comes the second stage, which is model formulation. Model formulation involves translating economic theory into a mathematical equation. For that, the first step is to choose the appropriate variables, functional forms, or hypotheses to be tested. Once you are done with the collection of data on the variables of your study, you should be clearly defining your dependent variable and the independent variable. For example, if you want to study what is the impact of trade on economic growth, in this case, trade would be the independent variable, whereas economic growth would be your dependent variable. Once you are done with the formulation of your model, the third stage is estimation technique. The goal of estimation is to find best fitting values for the parameters of your model. Ordinary least square, also known as regression or OLS, is a common technique for linear regression models, while other techniques such as maximum likelihood estimation are used for more complex models. In fourth stage, model evaluation, we check the goodness of fit, which means we check the extent to which observed data matches the values expected by theory. And we also check the statistical significance of our results. To check goodness of fit, we use R square, which measures how well our model explains the variation in the dependent variable. In simple words, how much variation in the dependent variable is caused by the independent variables of the model. On the other hand, we use hypothesis testings to determine whether coefficients are significantly different from zero or not. Okay, then there comes stage 5, which is policy analysis and model use. This can involve predicting outcomes, that is, we can do forecasting based on our results, and we can use the results to assess policy effects or make informed business decisions. Here we have discussed the 5 stages of econometric process, and now we are going to discuss the art of model building. Model building is both a science and an art. When constructing a statistical or econometric model, several factors come into play. The first factor is theoretical understanding. This refers to the understanding of the underlying relationships and mechanisms at work in the phenomenon you are studying. A strong theoretical foundation helps you choose the right variables and formulate hypotheses about how they are related. So it's very important to understand the theory first, then make your model according to theory. The second factor is domain knowledge. Your familiarity with the specific field of study is crucial. Domain knowledge helps you interpret results, select relevant variables, and make informed decisions about the structure of your model. The third factor is data availability. The availability and quality of data shape your modeling choices. You might need to adjust your model depending on the data scope, granularity, and reliability. At the end, you need to be cautious of